In our previous video, I started talking about the techniques in solving limits. I talked about dividing out technique. So in this video, I'll be talking about another technique called rationalizing technique. And I'll be solving 4 examples. If I'm able to finish the 4 examples, I will do 2. Then in the next video, I will complete the examples. Now let's get started. The first example here, we are asked to evaluate limit when x tends to 0 square root of x plus 1 minus 1 or divided by x. So this is the function that is given to us. So we are asked to solve this. So rationalizing techniques is also like dividing out technique. What you have to do here is we have to check by plugging in what our x is tending to. In this case, x is tending to 0. So we'll be plugging in 0. We're replacing our x with 0 in this function to check if we'll arrive at our answer or we'll get 0 divided by 0. I told you in that dividing out technique that if your answer, if you try to check and you put what x is tending to in your function and you see that your answer is 0 divided by 0, then you have to use another method in solving the limit. So same thing is applicable here. We'll plug in our 0 in this function here. Let's plug it in. If we put 0 here, we have root of 0 plus 1 minus 1 divided by 0. We find out that this one will give us root 1 minus 1 divided by 0. 1 minus root 1 is 1. Root 1 is 1, so 1 minus 1, that's 0 divided by 0. As you can see, we are still getting 0 divided by 0 here. So we cannot leave our answer like this. So we have to use either dividing out technique or rationalizing technique. So in this case, we'll be using rationalizing technique because I've already talked about dividing out technique. So what we have to do here is we have to look at our function here and look for the one that is more complex. X, this function at the top is much more complex than x. So we'll be multiplying our function with this complex function here. So let's write it out again. We have limit x tends to 0 square root of x plus 1 minus 1 divided by x. So we multiply it by this complex function, which is root x plus 1. So note that when you are trying to use the complex function, you have to change the sign. In this case, the sign, we have a function here. As you can see, we have a function here. We also have one here. What is separating them is negative. So this negative will turn to positive when you are trying to multiply it. Then you change it to plus 1 divided by root x plus 1 plus 1. So that's the first step. So we want to multiply our function by this. What do we have? We have limit when x tends to 0. This multiplied by this, we have x plus 1 squared, then minus 1 times plus 1 down will give us minus 1 squared divided by again, x multiplied by this, we have x root x plus 1, then plus 1. How did I get this? We only have one. We only have x here, so you multiply it by this. So that's how I put my. That's why I put my x here and I put this function here. So this is what we have. Then we can now cancel some things out now. This 2 will be cancelled with this root. So what do we have? We will have equal to limit x tends to 0. What do we have left? X plus 1 minus 1 squared is 1 divided by x plus 1 plus 1. Yes, so we have positive 1, we have negative 1, so they will also cancel. This will cancel with this, equal to limit x tends to 0. We have x divided by x plus 1 plus 1. As you can see, we are already eliminating our function. So here we also have x, we have x here as well. They will cancel. This x will cancel with this x. So we have 1 here. X here goes here 1 time. It also goes here 1 time. So we have 1 here. We now write it out again. Limit x tends to 0. What do you have left? We have 1 over square root of x plus 1 plus 1. So this is what we have left. Now we can now put what our x is tending to, which is 0. We can now put it in our function right now. Let's put it there. We have 1 divided by 0 plus 1. I'm replacing our x with 0. What our x is tending to, which is 0. Then plus 1. We have 1 divided by root 0 plus 1 is 1 plus 1. So our final answer will be so our final answer will be our final answer will be 1 divided by root 1 is 1. So 1 plus 1, that is 2. So our final answer will be 1 over 2. So that's our answer. So that's the first example I have here. Then we'll be solving another example. Second example, we have a second example. We actually evaluate limit when x tends to 0 as well, x divided by root 2 plus x minus root 2. So this is the function that we have to evaluate. So we'll use the same method here. We'll use rationalizing technique to solve this. So let's try and check if our answer will be 0 divided by 0. If it's 0 divided by 0, then you have to use a technique to solve our limit. That's the first thing you have to check. Now let's check. Let's put 0 in, let's replace x with 0. If we replace x with 0, we have 0 divided by root of 2 plus 0 minus root 2. which will be equal to 0 divided by, you have root 2 minus root 2. So we have positive root 2, negative root 2. So that one will cancel. Our answer will be 0 divided by 0 if we evaluate this. So we can't leave it like this. So we have to use the technique again, which is rationalizing technique, the one we used in the previous example. So I told you in the previous example that you have to look for the complex equation here. This one is much more complex than x, so we'll be multiplying our function with this with the denominator. So let's write out our function again. Limit x tends to 0, x divided by root 2 plus x minus root 2. So this is what we have. Then we multiply it by our complex equation, which is the one in the denominator. We have root 2 plus x. Then I told in the previous video that the sign will change. The sign will change. Here we have this. What is separating them is negative, so we'll be using positive here. You have to flip the sign. Positive root 2 divided by root 2 plus x plus root 2. So this is what we will have here. So we start multiplying it. We now have limit x tends to 0, x, then root 2 plus x plus 2 plus root 2, sorry, plus root 2 plus root 2 divided by, then this one multiplied by this will give us root 2 plus x squared. Then this multiplied by this will give us negative root 2 squared. As you can see, this multiplied by this will give us this, and this negative multiplied by positive is negative. Then root 2 multiplied by root 2 will give us root 2 squared. So I have this. Then again, this will cancel with this, and this will cancel with the square root. So we now have limit x tends to 0, x root 2 plus x plus root 2 divided by 2 plus x minus 2. Yes. So this is what we have so far. So now we now cancel once again. We have positive 2, we have negative 2. So this one will cancel with this. We write our function out again, our equation out again. Limit x tends to 0, x root 2 plus x plus root 2 divided by x. So this is what we have left. Then again, we have x here, we also have x here. They will cancel. Now what do we have left? We have limit x tends to 0, 2 plus x plus root 2. So this is what we have left. Now we can now plug in what x is tending to, which is 0. So let's write it out. Equal to We now have root 2 plus 0 plus root 2. So we have equal to, we have root 2 plus root 2. This is what we have. So our answer will be equal to 2 root 2. So that's the answer for this this function, that is this limit that is given to us. So let's recap. What have I done so far? This video I talked about I've talked about rationalizing technique. The first thing you have to do, if any function or equation is given to you, this one is given to us, you have to put in what x is tending to. It's tending to 0 in this case. Then we find out that our answer is 0 divided by 0. Then that's when our rationalizing technique comes in, because it's equal to, our answer is equal to 0 divided by 0. So you have to choose the much more complex equation between this and this. We see that this one is much more complex than x. So you multiply it by your limit. So that's why I put this. Then whenever you want to multiply it, your the sign must flip. We have this function here, we also have one separately. This sign here must flip. So I flip it and I change, instead of this negative, I replace it with positive. Then I multiply it by this. That's how I got this. And we continue to break it down till we find our final answer. So same thing, we did the same thing in the second example. We check it once again. We find out our answer is 0 divided by 0. So we use the technique again to break it down. So that's all for this video. In the next video, I'm going to solve 2 more examples on rationalizing technique. Thanks for watching.